If you look at the energy utilities, traditionally these utilities have been designed maybe 20, 30 years ago, and they've been operating in that particular paradigm for a very long time. In the recent times, with the advent of distributed energy resources and also in rapid adoption of electric vehicles, there is a paradigm shift that is happening not just in the delivery of electricity, but also in the generation of electricity. In other words, many of the homes, they are now becoming net producers of electricity because they have solar panels in their homes, which are generating more electricity than what they are consuming. So now that generated electricity has to go somewhere. So that essentially puts a lot of stress on the power grid, and the electric utility companies are not necessarily geared up to handle this particular problem. Because of this increased stress in the power grids, now the power utility companies will now have to deploy more substations to manage this changing demands of electrical energy. So that means that they need to be able to bring up these substations faster and manage it and operate it on an ongoing basis. So scale of operations, the speed of deploying the solution. So those two things are significantly challenging for them. The third important challenge is most of these components that you see in a typical substation, majority of the times these are nothing but hardware appliances that were designed again 10, 15, 20 years ago. Now that gives them very limited scope for extension or evolution. So what they are now looking for is to virtualize or modernize their substation so that now they can introduce new capabilities and new services as they become available or as it becomes necessary to balance the grid at the ground, and also be able to operate it in an autonomous fashion, because many of these substations are going to be in remote outskirts where they may not have easy access to send somebody to go and troubleshoot these substation equipment. So you need to manage them in a remote fashion. One of the key areas that these utility companies are doing is how to address this rapid stress that they are seeing in their networks. And for that, the first goal is to be able to collect statistics on the various elements that are governing the delivery of these energy power. So for that, they need a lot of AI/ML techniques that they want to apply, and they want to collect statistics from all these substations and all these individual home as well, which is generating power. The virtualization of all these substations, we now have an opportunity to not only collect and store this data, but also be able to feed it back to the purpose-built AI/ML engines that can analyze this data to come up with a mechanism as to how they can balance the grid more effectively so that they can extend the life of all the electrical systems that is deployed in their network. So what they are essentially doing is now they're going through this modernization process where they are completely virtualizing all their substation components, like particularly the protection, automation, and control components. And so that now, instead of deploying about 5 different appliances for each of these functions, now they are virtualizing all these protection, automation, control elements and running it on a single COTS server. So that way they not only reduce their hardware footprint, but also make it more like a cookie cutter approach where they can deploy these new substations much faster than what they are used to in the past. So this is one of the places where edge compute, particularly with its autonomous operations capability through VECO, is lending significant benefit for utilities to modernize their grid.